Okay, so from yesterday, right, what we're looking at now, 3.5 is about converting from standard form to vertex form. So let's look at this diagram for a second. So this really explains the processes we would use to switch back and forth between standard form and vertex form. So if we wanted to start in vertex form and write it in standard form, all that means is we're just simplifying, right? We're just going to multiply this thing out and collect like terms. We'll do more of that when we get into polynomials in Unit 5. We won't do a lot of it for now. I mean, but we could all do that right now, right? I would just follow order of operations, and I would do this exponent first. So I'd have x minus h squared is x minus h times x minus h. Multiply all that out. Then I would distribute an a, right? And then I would just add a k, add that number, combine like terms, and magically we would be in standard form. This is really just simplified form, okay? Okay, but what we're more focused on is the opposite, is starting at standard form and ending up in vertex form. We have two options. First one is probably the easiest. That's the one where we just calculate what h and k are and plug those into, and we already know what a is, right? A is the same in both forms. We calculate h, calculate k, and then plug those numbers into my vertex form template. That's nothing we couldn't have done last unit or last section, right? What I'm showing you, the second option, is the one that's probably you're thinking is a little bit weird, and that's the completing the square one. You don't even really have to do that this section. I would encourage you to, because the reason I'm doing this now is so it's not so new next unit when we use completing the square to solve quadratic equations. And then it is important, right? Then it is something you're going to have to do. So you might as well learn it now. All right, so here's just a quick, this is on your note sheet, quick summary of how we would write quadratics in vertex form without completing the square, as we talked about. We're just going to calculate h, calculate k, and then using the values of a, h, and k, just plug them into the template. Done. That's the easiest way. Okay, and here's an example we did. Well, actually, we didn't do this one yesterday. We did the one before this, but here's what this one would look like, right? If we just zip through this really fast. There's a quadratic function in standard form, ax squared plus bx plus c, where a is -2, b is 20, c is -46, right? So all I'd have to do then is use my formula for h. H is -b over 2a, so that would be -20 over 2 times -2 is -4, -20 over -4 is 5. There's h. K is equal to f of h, right? So we're just going to plug that into the original function, plug that 5 in. So I'm going to get -2 times 5 squared plus 20 times 5 minus 46. And if I simplify all that, I get 4. So then I know that h is 5, k is 4, a is 2. Just plug those numbers into vertex form for a quadratic function, and we're done. Okay. All right, moving on though with this new technique, completing the square, right? And let's just go through another example of this. We did one yesterday. I think, didn't we do one yesterday? Maybe we didn't get through it. Let's use this example and let's complete the square. Okay, let's put this into vertex form. So what do I do first? If I'm going to complete the square, do you remember? What was our first step? Okay, yeah, so first step, we want to set it equal to y, already done. That one's already done, right? So there we have it, already set. What's next? Good, and the reason is we want to get the x squared plus bx terms by themselves on the right side. So we've just got to use algebra to make that happen. In this case, it just means subtracting a 5 to the y side. Okay, so we get that. Okay, give me thumbs on that. We good? Okay, what's next? What do we do next? This is the actual completing the square part. We haven't really done anything to complete the square. This is where we've got to add just the right number to both sides because I have an equation. I have to treat them equally, but I'm really trying to work on the right side here. I want to add just the right number to turn the right side into a perfect square trinomial. Okay, what's my recipe for doing that? How am I going to pick the number that I add to x squared plus 6x? B over 2 squared. So half of b is 6, right? Half of b would be 3. Okay, and I need to square that. So I'm going to add 3 squared to both sides. Okay. Now that's going to give me on the right side, I don't even have to write this out, but on the right side, that's going to give me x squared plus 6x plus 9. What are the magic numbers I would use to factor that? 3 and 3, right? They have to multiply to 9 and add to 6. So what do you know? That means it's a perfect square trinomial if we get the same magic number twice. Okay, so on the left side, y minus 5 plus 3 squared is just y minus 5 plus 9. I can just simplify that, right? On the right side, what do we get? Well, you just told me the magic number was 3 twice. Did I even have to write this out, though? No, I didn't have to. Because every time, whatever the number is that I'm squaring, it's wrong color. Oh, my goodness. The number that I'm squaring is always the same number that's going to be my magic number that shows up twice. So you don't even have to really write this out. I already know what I'm going to get on the right side. Okay. So now I have completed the square. I created a perfect square trinomial. What's the last part of this process? Yeah, subtract 4 because I need to solve for y again, right? How come? Because y is what what my quadratic function is equal to, right? I'm just trying to rewrite my quadratic function in a different form. So I still it needs to be equal to y again, right? Because y is what I started with. Okay. So we'll go back down and we'll re-isolate y and we're done. Just reverse the order of operations, get the y by itself, which means I'm just going to subtract 4, but I'm subtracting 4 outside of everything now, right? Does that make sense? Okay, so that's my answer. Okay, see the process? Okay, that's completing the square. Let's try another example. Okay, how about this one? Okay, so what do I do first? Okay, so well, it's already equal to y. So we got that first one. It's already equal to y. Now what? Okay, I'm going to have to add, there's going to be a couple parts to this, right? Because I want to get this in the form. But the first step, you're exactly right, is add 46. I want to get this into the form on the right side, x squared plus bx, right? So I have to get rid of the 46. And what's the next thing I'm going to do? I need it to be x squared, not negative 2x squared. Divide by negative 2, right? So, okay, so first I'm going to add 46. So we added 46. Then we divide by 2, okay? When I divide the right side by 2, I have to divide every term by 2. So that's going to give me an x squared, or by negative 2, sorry. 20x divided by negative 2 is negative 10x, right? On the other side, I've got y plus 46 divided by negative 2, okay? Do I need to try to simplify the left side? I wouldn't. There's no reason to, right? We're just going to undo that eventually anyway, okay? So now the right side is all set. We got it to look like what we wanted it to look like. We got it to look like x squared plus bx. So what's going to be the number I'm going to have to add to both sides to make the right side into a perfect square trinomial? Negative 5 squared. Half of b, which is negative 10, right? So I'm going to add negative 5 squared. Okay, we know b over 2 is negative 5. So I'm adding negative 5 squared to both sides. What does that mean on the right side that's going to factor into? Yeah, there it is. X plus -5 quantity squared. I already know that -5, that's the number I'm squaring, is going to be my magic number that shows up twice. So on the right side, I'm guaranteed to get that, right? X plus -5, which is X minus 5 squared. On the left side, well, -5 squared will make that a 25, right? But otherwise, we don't want to mess around with the left side. We don't need to do a bunch of work there because now we're just going to isolate the y anyway, which means we're just going to reverse the order of everything we did to stack stuff on the left side. What's the last thing we shoved over to the right side or left side? We added 25, right? Well, so then we're just going to subtract 25 first, which is consistent with order of operations, right? I mean, think about order of operations tree for a second. This is kind of cool in math how this is gonna be exactly consistent with all these theories we've talked about in math, right? We've talked about these principles. With order of operations tree, we always said that we go top to bottom when we're simplifying, right? And we go bottom to top when we're isolating, okay? Well, what are we trying to do now? We're trying to isolate the y. So what do we do first? We're going to add or subtract outside of parentheses. There are implied parentheses around the top and the bottom of that fraction bar, right? So the first thing we'd have to do then, step one, would be we're going to subtract 25 from both sides, right? It's not an accident that that's the last thing we did up here. We added 25 to both sides. Now we're just going to work backwards and subtract it. So we add the 25 or subtract the 25 to the right side. Now what? Yeah, I got to multiply by -2, right? Again, how come? Because I've got implied parentheses around the top. So if I work my way up, the next thing I would do is multiply or divide outside of parentheses. Yeah, I got to multiply by -2. So the next step would be that one, okay? If I multiply each side by -2, it's going to cancel the -2 from the denominator. So I just end up with y plus 46. What do I get on the right side? If I multiply by -2, I have to multiply the whole right side by -2, right? How many terms are there on the right side? How many things are being added or subtracted there? No, 2. Because I've got, yeah, there's a minus sign between the x and the 5, but that's all inside the quantity that's being squared, right? I've got this one term minus 25. I've got one term minus another term. So I'm going to distribute, my point is, I'm going to distribute that -2 to the first term. Well, what's -2 times x minus 5 quantity squared? I cannot distribute inside that because all that stuff is being squared. Everybody get that? Right? What is x minus 5 quantity squared? That's really more complicated. It's x minus 5 times x minus 5. And if I wanted to figure out what that was, I'd have to multiply all those out and collect like terms. We haven't done that yet. So I can't distribute the -2 inside something that's being squared. All I can do is distribute it so it's being multiplied by that term right there. -2 times the quantity x minus 5 squared. That's starting to look familiar though. Doesn't that look like a times the quantity x minus h squared, right? Then I distribute the -2 to the -25 and I get positive 50. Okay. So how are we doing? Give me 1 to 5 so far on this. Okay. I mean, it's a lot, but every time we go through it, it's just going to make more sense. What's the last thing I have to do here to isolate the y? Subtract 46. So if I subtract 46 from the left side, it goes away. If I subtract it from the right side, that's the same thing. Subtracting 46 is the same thing as doing this, right? Oops. So those guys cancel. Over here, I'm just collecting like terms. I'm just going to add up all the numbers. Well, there's only two numbers here that aren't being multiplied by stuff, right? So 50 minus 46 is 4, and I'm done. Okay. Think back up here to this step right here. You can map out all the next steps if you just think carefully about the order of things I'm going to have to do to isolate the y. What would I do first? What do I have to do first to isolate the y? Subtract 25. Then what? Multiply by -2, then subtract 46, and we got it. Okay? Those are the steps we did, aren't they? Okay? All right. So there's our answer then, right? So y, which was originally equal to all this stuff, is now equal to that stuff. So what did we end up doing? We just converted standard form to vertex form. Yes, sir. Yeah, you bet. Okay. Let's look at one more of those. Okay, one more of those. So we want to, let's see, is that a good one? Yeah, that is. Okay. All right. Let's go through the process. What would I do first if I want to convert this into vertex form by completing the square? Okay, well, but what do I do even before that? There's one really nitpicky little minor step. Yeah, let's make it a y, just so it's easier to see what's going on, right? It's less visually confusing. And so we make this a y. Okay, now what? What's next? Okay, I got to add 5. Good, I got to get rid of that term. So we could add 5 to both sides. Those guys cancel. So I get y plus 5 equals -1/2 x squared minus 4x. Okay, now think about this one carefully. What am I going to do next here? Well, that's a big x, isn't it? Yeah, I need to get an x squared there, not a -1/2 x squared. How do I undo multiplying by -1/2? Yeah, multiply by -2. Okay, so we could take the entire thing and distribute through a -2, right? Okay, do I distribute on the left? I can, it doesn't matter. I mean, I can leave it as -2 times that quantity, or I could go ahead and distribute it. That gives me -2y minus 10, right, on the left side. What do I get on the right side? Okay. Now what? I'm going to give myself a little more room here. Okay, so what? Say it again. What am I adding to both sides? 4 squared. Okay, so I'm adding half of 8, which is 4 squared. Well, that's just 16. I'm just going to write it as 16 on the left side. On the right side, I left it this way because what's that going to factor into? There you go. X plus 4 squared. On the left side, I could just combine like terms, and I've got negative 2y plus 6. Well, what are the last two steps to get y by itself? Good, I got to subtract 6 first, and then divide by -2, and I'm there, right? So if we subtract 6, I'm going to put that out there, right? Because those are obviously unlike terms. These guys cancel. We divide both sides by -2. And dividing by -2, that's okay to do. That's fine. what's another way of thinking about dividing by -2? Yeah, multiplying by -1/2. I think that's an easier way to think about this, right? If we multiply -1/2 times x plus 4 squared minus 6. It's the same thing, right? Dividing, if I were to divide this first term by -2, that's the same thing as getting 1 over -2 times that, right? It just seems a little bit easier to distribute though. So what's that give us then? We cancel the -2's, so I get y equals, if I distribute to that first term, what do I end up with, Tyler? Help me write down. What should I write down here? Good. Plus 3. Done. Okay. Okay, that's it. So we know, where's the vertex? -4, 3. And the vertical dilation factor? -1/2. Easy. Okay. Why don't we? That's probably good. Why don't you guys? You can work.